example 4, I'm going to start with my coordinate plane. We're going to graph these two, so I'm going to draw the f of x in blue. Alright, this one looks something like this. Here's my f of x function. G of x, a little too straight there. There you get something like this. So in this case, we actually have two different regions. We have this first region, and we have this second region here. So I'm going to do those a little bit separately. Okay, this, again, we're going to have, this is a delta x. This is the difference, it was an x width. Alright, this is also delta x. Our height on this function would equal f of x minus g of x. Our height on this one is g of x minus f of x. So these are going to be a little bit different. Now we just need to find the points of intersection. And so we need to figure out, where is this equal to this? Alright, so you can, maybe if we move everything to one side, it'll be easier. So the x squareds cancel out. I get minus 10x minus 2x, so minus 12x. Factor out of 3x, we get x squared minus 4 equals 0. The points of intersection are going to be x equals 0 and x equals plus or minus 2. So we have x equals negative 2, 0, and 2. So now we just need to set up our integral. The area is equal to the integral from negative 2 to 0 of f of x minus g of x dx plus the area going from 0 to 2 of g of x minus f of x dx. Okay, you can do that by hand, or for now, just for the sake of time, with a calculator. And I believe that you end up with 24 units. Example 5. Now, this is going to be kind of a neat introduction to our next idea. We're going to use a vertical slicing method, which is what we've been using this whole time. And then I'm going to show you another way to do this. So my f of x is going to be a square root of x. My g of x is going to be x minus 2, which would look something like this. And we're going to find the area of the region in the first quadrant. So I only want this here. Okay, so as we go, and if you weren't sure, this is x equals 2. Okay, this is the point x equals 4. You could do it by setting them equal to each other, or just logic here. So to find the area of this region, I should say what I'm doing, area equals, and also we didn't talk about the height, right? From 0 to 2, the height is strictly given by f of x minus 0, because we're only going to this 0. Okay, and then I have my height after that is f of x minus g of x. Okay, that would be this section here. And my width is a delta x. So I'm going to have two different areas. I'm going to go from 0 to 2 of square root of x minus 0. Plus, then I'm going to go from 2 to 4, x equals 2 to x equals 4 of f of x, which is square root of x, minus x minus 2 dx. Alright, integrating. This, I'm going to just rewrite this. You don't have to, but maybe it'll make it easier. Alright, plus 2 to 4, x to the 1/2 minus x plus 2 dx. There we go. Add 1 to the power, divide by the new power. And we're going to evaluate that from 0 to 2, sorry. Then we get over here 2/3 x cubed to the 3/2 minus 1/2 x squared plus 2x, evaluated from 2 to 4. So if I plug these in, I'm going to leave this alone for right now. I get 2/3 times 2 to the 3/2 minus 0. So I'm going to leave that there. Then I'm subtracting 2/3 times 4 to the 3/2. Okay, minus 1/2 times 4 squared. Okay, so we have 1/2 times 16, which is minus 8. Then we have plus 2 times 4, which is plus 8. Oh, and that is actually a plus between there. Didn't want to mess that up. Okay, minus now 2/3 times 2 to the 3/2 minus 1/2 times 2 squared, which is 4, so half of that's 2, plus 4. Alright, as I start to simplify this, I don't feel like doing this yet, so I'm going to leave it there. This is a lot of work, though. Alright, 4, the square root of 4 is 2. 2 cubed is 8. 8 times 2, 16, so I'm going to get 16/3. Minus 8 plus 8, they'll cancel out. Now I have minus 2/3 times 2 to the 3/2. And then I have inside minus 2 plus 4, so I get a plus 2, but it's really a minus 2. These cancel out. 16/3 minus 2, or 6/3, gives us a final answer of 10/3. So that's quite a bit of work. We had 2 different integrals. It's because we had different heights from 0 to 2, okay, and then from 2 to 4. So now here's going to be the changing factor. It's the same graph, the same exact graph, but we're going to have something a little bit different this time. Alright, so this is my g of x again. Well, actually, I'm not going to label that. I'm going to change it for a second. We're going to do this using a horizontal slicing method. So we're talking this way. So now my widths are no longer dx. Now my widths are dy. So to find my height this time, I need to go this way. Okay? So I'm going to have to do this green function. This time my height is a function of y. My green function, so I get to turn this into something in terms of y. So instead of having y equals this, if I solve this for x, I get y plus 2. If I solve this for x, okay, for my, I'm gonna call this right now g of y. If I solve this part for x, I'm gonna get y squared equals x, and I'm gonna call that f of y. Now to do the area, I need to use everything in terms of y values. So I got to figure out what y values these are. Well, I know that this point is 4, 2. I know that this point 0, 0. Okay, so when I talk about my height, right now I'm going to have this g of y minus f of y. So my area, because my height is this way this time, okay, my area is going to be found by going from y equals 0 to y equals 2 of g of x, which is y plus 2, minus f of x, which is y squared. And my rectangle, the width is dy. Integrating this, I get 1/2 y squared plus 2y minus 1/3 y cubed, evaluated from 0 to 2. Plugging 2 into this is not too bad. It's 1/2 times 4 plus 4 minus 8/3. Then I have minus 0. So 2 plus 4 is 6. I get 6 minus 8/3. 6 is the same as 18/3, so I get an answer of 10/3, and that was a little bit easier. So there are 2 main methods here. We have the vertical slicing, which is using a dx. Everything needs to be a function in terms of x. And then we have this horizontal slicing method, where this time everything's in terms of y. So it's good to practice that again. So we'll try one more with the y Find the area enclosed by this. So it's good to get a picture. Alright, this here, it's y. It's on the side this time, so it's going to look something like this. Alright, I'm going to call that f of y. And then I need to put this function in terms of y. So that's going to be, instead of that, alright, it's going to be x equals the cube root of y. And either way, we should know what that graph is like. It looks something like this. So the reason why I wouldn't do a vertical slicing method is because this part would be fine. But when you get here, this isn't f of y minus g of y. Okay, there's the f function. So we can't use that specific height there. So maybe if we do it this way, is the green function always on the right side? And it is. Okay, so it's always the green to the blue, green to the blue, green to the blue. So now we just need these y values, and we can integrate. You can find those on your calculator. Okay, I'm going to save you a little bit of time. It's going to be y equals -1 and y equals 1.793 about. Okay, those are these two y values. So now to find the area, we should also mention the height, right? Our height of our rectangle is in terms of y, and we're doing our g of y minus f of y. This is one you could do by hand, but for the sake of time, I'm going to show you. All right, so we're going from -1, y equals -1, to 1.7, whatever, 793. And my height, since I already wrote it out here, it's pretty easy. G of y. And since I labeled it as g of y, I can write it down here. Minus f of y dy. Type that into your calculator. And I believe you get about 4.214. Alright, so hopefully you'll get this idea. It's kind of neat. It doesn't matter which way you go, but you have to be careful. If a function like this, if we took this height to get to that green height, there's going to be some that's not quite right. So we had to use the horizontal slicing method here. Okay, try some examples in your worksheet. We're going to go over example 8 in class. Have a nice day.